So what do mathematicians mean when they write an exponent that's a fraction, like 2/3? We have x to the 2/3. What does that mean? Well, its meaning, according to mathematicians, could be one of two things. It could mean that you start with the base, and then you take the cube root, the third root. You always use the denominator of your fractional exponent for the index of the root. And then, when you're done doing that, you take that result to the second power. The top of the fraction, the numerator of the fraction, is always the power. Taking the cube root of x kind of tears it down, and then taking the square of that kind of builds it back up. There is a second thing that this could be defined as, and that is you could start with the base always, and then take the second power first. It's still a power. And then when you're all done taking the second power, take the cube root. Either of these is an acceptable way to write this base to a fractional power as a root. Now what happens if instead of x you have 8 to the 2/3 power? Well, you can still take the cube root of 8 first. Always use this for your index for your root, and then square it, in which case this would be a 2 squared, because the cube root of 8 is 2. 2 times 2, 2 squared is 4. That's pretty convenient. Notice what happens if you do the other direction. If you first of all square 8 and then take the cube root, your numbers in the problem get a little bigger. 8 squared is 64, and then you got to figure out the cube root of 64, and that's not too bad. It's still 4. And you can see it doesn't matter which order you do this in. You could take the cube root first and then square, or square and then take the cube root. But these numbers are getting a little bigger, so in general I like this better when I'm dealing with numbers because it keeps the numbers smaller. In this problem, we're not starting with a fractional exponent and then writing it with roots. This time we have something written with roots, and we want to see if we can write it with a fractional exponent. And so this root index will be the denominator of a fractional exponent. And this power, the power is always the numerator of the fractional exponent. And then this thing inside the root symbol is always the base that goes with the fractional exponent. So 3x squared y to the 7/5 power is the same thing as the 5th root of 3x squared y all to the 7th power. And so often we're asked to start here and write this way, or start here and write this way. Notice both of these are the same thing as 3x squared y, first of all to the 7th power, and then and only then the 5th root. It doesn't matter if you take the 5th root first and then the 7th power, or if you take the 7th power first and then the 5th root. But in this problem, I was asking us to go from a root quantity to a fractional exponent quantity. Let's do a few problems. If we want to calculate what this equals without a calculator, I would suggest not squaring 125. That's going to be pretty big. But I'd suggest taking the cube root of the 125 to the second power. Now the cube root of 125 is something you can multiply by itself 3 times to get 125. It's 5 times 5 times 5. So the cube root of 125 is 5. And then we're taking that and we're squaring it. So this is 25. 125 to the 2/3 power is 25. Here the directions are to write this using a fractional exponent. So the power of 2 will be the numerator of the fraction, the index of the root will be the denominator of the fraction, and this will be the base. So we have x to the 2/11 power, and we're done. Here it's the opposite direction. We're asked to take this and write it with a root symbol. And so that's a little bit more challenging because we have a negative sign in front of the 2/3. So I'm going to change the directions. I'm going to ask us to think of writing this quantity using positive exponents only. One way to interpret a negative exponent is as the reciprocal. So we can write that this equals 1 on top of the same base, it doesn't change, 3xy, to the 2/3 power. All right, let's move on. We can treat exponents that are fractions just exactly like if they weren't fractions. So for instance, we had a rule that said x to the second to the third was x to the sixth, that a power to a power you could multiply. And so this will be x to whatever the 2/3 times 3/4 power is. If you multiply 2/3 times 3/4, you'll get a half. So this equals x to the 1/2 power. Here, when you're multiplying things that have like bases, we learned from before that you could add exponents. 2 plus 3 would be 5. So this is 2 of them, 3 of them. Altogether, you're multiplying 5 of them. So that means this will be x to the 2/3 plus 3/4. In order to figure out what that is, we're going to need common denominators. Common denominator is 12. Here we're multiplying top and bottom by 4 to get the bottom to be 12, so we have 8 12s. Here we're multiplying top and bottom by 3 to get the bottom to be 12, so we have 9 12s. And so 8 plus 9 is 17 12s. And so this was harder than this last problem. This one was actually easier. And what do we do here? Well, we had the idea that x to the 5th over x to the 3rd was x to the 5 minus 3, or x squared. In other words, 3 of these 5 would cancel out these, and there'd be 2 left over on top. So that means that we have x to the 2/3 power minus 3/4 power. Using our common denominators from before, on the last problem, that would be 8 12s minus 9 12s, which would be x to the negative 1/12. That's a perfectly good answer, unless you're asked to use positive exponents only, in which case we'd write the reciprocal. That kind of means the reciprocal of x to the 1/12. So it'll be 1 over x to the positive 1/12. Both of these are good answers, and that's a pretty good review of the kinds of things that you'll see in this section.